So I got another optimization question from a Cal 1 student. This one is, you have a rectangular piece of paper, and this piece of paper has some print on it, and the print is 882, let's say, square inches, and there's 2-inch margins on the top and bottom, and 1-inch margins on the side. And what they want is the minimum paper area. And so I'll set this one up for you. Since it's a rectangle, right, we can let this side be y, we can let this side be x. Then I think this side of the printed area would be what? Y minus 4. And this side of the printed area would be x minus 2. So the area of the paper, which is what we want to minimize, is optimization. So this is going to be our objective function, right? The area of the paper is going to be xy. This is what we're going to take the derivative of and set equal to 0. Then our constraint is going to be this, right? So it's going to be y minus 4 times x minus 2, and that's going to be 882. So we need to multiply this thing out and solve it, and then plug it into our objective functions, okay? So let's see, we would end up with something like xy minus 2y minus 4x plus 8 equals 882. Here you end up with y x minus 2 equals 882 minus 8 plus 4x. So here you have y equals 882 minus 4, 882 minus 8, right? So this would be 874 plus 4x over x minus 2. Okay, so this would be our y. Plug that in here to our objective function, so we get a equals x, y. So y is, let's make y 4x plus 874 over x minus 2, so a equals 4x squared plus 874x over x minus 2. So we're going to take the derivative of this using quotient rule. You remember quotient rule. And then on the bottom of our quotient rule, we're going to have x minus 2 squared. This means that this isn't going to work if x equals 2, right? But x can't be 2 because x is the bottom of the paper. The margins are 1 inches on each side. So if x were 2, it would be 0. So that doesn't work. So we don't have to worry about the bottom. So we'll just set the top equal to 0, and that'll give us x. So I'm going to leave it here. You finish it up. Hopefully this makes sense. If it doesn't, send me another email, and we'll work it in more detail.